Alright, welcome to Chapter 4, Wireless LANs. So, we're going to talk about LAN concepts, how LANs operate, how to secure your LAN, and how to configure your LAN. Now, some of you think, oh, I already know everything about wireless, blah, blah, blah. Well, again, we're going to talk about a little bit about AC and AD, so you may want to listen a little bit. Alright, so concepts. Obviously, the big draw for wireless is mobility. You know, I can take my laptop with me anywhere. I can have my tablet with me anywhere. I can work at home. I can work at the bus stop. I can work wherever I need to go. And that's the big thing. You know, I can roam around the building. I can relax somewhere and sit down and watch the outside while I'm working and be more productive, theoretically. So again, benefits, we're more flexible. And we can also increase our productivity. Some people say, well, I can do stuff at lunch because I'm sitting outside and then can relax and do this. Another way it increases productivity is you no longer have to have a cabling guy or an IT guy come over when somebody moves from one desk, to another room and unplug everything and move everything. The person can move their laptop themselves. Now, they say it reduces cost. The only cost I know of would be obviously if you got 24 laptops, you just buy 1 or 2 access points, where if you got 24 laptops, you got to go buy 24 port switch. And if you got 24, you might as well buy a 48 for growth. So that would be an extra cost plus the cabling that needs for those 24 people. So that kind of thing. But again, you got to take that with a grain of salt. Most buildings are already wired, so you're not really going to reduce the cost. And I don't know anybody that says, hey, I'm going to hire 20 new people and give them all laptops because it's going to reduce my cost. Because obviously, typically, laptops are more expensive than desktops. So again, anytime you're dealing with vendors, or like obviously Cisco is a big vendor, you have to take some of the stuff that they say with a grain of salt. But again, I got this ability to grow and adapt, and I can put different wireless cards in there, and I can switch from G to the N protocol to the AC protocol and stuff like that. So it's a lot easier to keep up. All right, different wireless kinds of networks or technologies. First one is the wireless PAN. And basically, it operates on Bluetooth. Now, the military years ago was testing, and I'm sure they've got some of these in production, but not for the common soldier. But they have suits or uniforms where the soldier has a GPS, he's got a laser rangefinder, he's got binoculars, he's got a radio, and everything is networked together, and everything's wireless that goes back to, through satellite, back to headquarters. So headquarters can see what he sees, they know exactly where he's at, they can use his laser rangefinder information to, drop bombs on people, all kinds of neat stuff. So for us, our wireless PAN is like our Bluetooth keyboard, mouse, and phone headset, and that kind of stuff. Then there's obviously our wireless LAN, which is your regular network. Then there's a wireless wide area network. Really, that's more like a wireless MAN. You're talking about like a city that does wireless. Then there's Bluetooth. We kind of already talked about that. Now, Wi-Fi is short for wireless fidelity. And the Wi-Fi standard says, hey, I can only go distances of up to 0.18 miles. So it's not a huge seller, but there are some places like in New York where there's so many people crowded together that they can push out Wi-Fi because 0.818 miles covers 5 buildings, and each building is I don't know, hundreds of people. So in bigger cities, some of these technologies obviously are much more prevalent than they are in ours. Then there's WiMAX. Remember, with WiMAX, we can go up to 30 miles. So you got these people that are buying bandwidth, and then they're running cable to cell towers and tall buildings and put up their WiMAX receivers, and then they're sending out a wireless signal. Then they run around that wireless signal to the different houses, and they try to sell that wireless internet. Then cellular, obviously we know what that is, and then satellite. All right, lots of different frequencies that are out there, from 3K to 300 gigahertz, that kind of stuff. Some are on the low end, some are on the high end. Some we can see, some we can't. So don't worry too much about this chart. Now, this one's kind of nice. Now remember, 802.11 was the first wireless standard. It said, hey, this is going to be wireless. So we're talking about the 90s. And then A and B came out in like 1999. They came out together. So A was faster, 54 megabits per second. B was slower, 11 megabits per second. But again, back in 1999, a lot of people still had Cat3 networks. So their max speed was 10. So to get a wireless network that did 11 was like, that's a no-brainer. So everybody went with B because the range was so much better. So A was in the 5 gigahertz frequency, B was in the 2.4. So then G came out, gave us almost the range of B, but gave us the speed of A, and then everybody moved over to G. It's been years since I saw anybody still running a B network, and I can't imagine anybody still is, unless it's, I don't know, Goodwill or something. So, and then the N protocol came out, and with the N protocol, now we've got powered antennas instead of these stupid dipole things, and we have multiple antennas to allow our multiple input, multiple output to kind of push a greater distance the signal. You know, the first signal goes out, and the second signal kind of rides across the first to go farther. So because of that, we got more speeds. Now here, they're saying a max speed of 600 megabits per second. Now you got to remember, when you see some of these max speeds, some of these are theoretical, like AC. Now here, it only says 1.3 gigs. But somewhere, the actual theoretical max standard for 11 AC is like 7 gigabits per second. But that's assuming you've got 7 transmitters and a bunch of other stuff that will never happen because that would be so expensive, it just wouldn't work. So always take these numbers with a grain of salt. But obviously N is much faster than G and has better range than G. Plus, if I'm in an apartment building and I'm running the N protocol, I got a choice between the 2.4 or the 5 gigahertz frequency. You know, if everybody else in my apartment is running 2.4 in the apartment buildings, and they're all running G, and it's interfering with my wireless, I can switch my wireless, receiver to the 5 gigahertz range, and then I'm much better. And then obviously I get a lot less interference. All right, then there's AD with 7 gigabits per second. Remember, that's theoretical. Now, AC, they say here 5 gigahertz, so I don't know how old this slide is, but my understanding is that with AC, they've also opened up the 80 gigahertz frequency, which allows some of these top speeds that they're talking about. But again, some of the equipment that's involved in that would put this way out of the price range of any normal company. So then AD, obviously AD is the fastest one, but you really have to look into it. Like, I found a bunch of stuff about AC that really theoretically says with the stuff that you buy at the store for the consumer. You know, we're only talking about one antenna, and the speed boost that it gives you really is targeted for certain types of traffic, like streaming media. So if you're running something like a Roku box, an AC would be great. But if you're actually trying to do a video game or something like that, you may not see a big benefit over the N protocol. So again, you have to really research this stuff. All right, so the Phi-Y Alliance certifies anything that's Wi-Fi. So again, you got the IEEE 802.1a, b, g, and blah blah compatible. You got the 11i secure using WPA and EAP. Remember, WPA2 with EAP encryption is supposed to be the best that we theoretically have as consumers. Then there's Phi-Y protected setup. If your wireless access point provides that, WPS, it helps to allow connection to devices be a lot simpler. There's a media sharing thing. There's one for setting up security real easy, especially like in hotspots. But you get the idea. All right. At the physical layer, for a wireless LAN, we're talking about radio frequencies. For our cable, we're talking about the cable. We're talking about pushing electrical impulses, that kind of thing. At the media access layer, remember, wireless runs on CSMA-CA, so it avoids collisions. How does wireless avoid collisions? Well, in layman's terms, it does time sharing. If 5 people want to all use their wireless at the same time, they all send a request to send. Then the wireless access point sends something to the first laptop and says, okay, you're clear to send for 0.18 milliseconds. And then the next one, you're clear to send for 0.18 milliseconds. Then the next one. So it's a timeshare. And that's why the more people you have on a wireless access point, the slower your speed. Even if all 5 people look at their wireless, all 5 is going to say 54 megabits per second if it's a G. But they're not really getting 54 megabits per second. They're getting 54 megabits per second when it's their turn. So again, make sure you're aware of that. All right, obviously you need a wireless NIC card. Years ago, the PCs and laptops did not come with wireless NICs. You had to buy a PCM-CIA card for a laptop. You had to buy a PCI card for or actually it was the old PC. What the heck was the original one? I can't even think of the name of it. The old black strips that for the bus that you plug cards in. Wow, it's been that long. ISA, that's ISA. So again, been a long time. But nowadays we have these little tiny ones like this. They're the size of a paper clip. You got the ones like we use in class like this. All right, and then obviously you need a wireless home router. And these comes in all shapes and sizes. For the consumer, they're typically plastic. They typically don't last forever, a couple years if you're lucky, depending on which model you buy. Some people have had them for a long time, but you've got to keep them in a well-ventilated area. You can't put them like in weird shelves and stuff like that where they can't breathe. Otherwise, they overheat. But what's nice is these home things, it's a router, it's a firewall, it's a wireless access point, and it's a switch all built into one. So it's still nice as a consumer that we can get all of that for the kind of price that we get. Remember, for a business, obviously that would cost thousands. All right, lots of ways to set up your wireless and lots of different terms and different stuff. So here, you've got a wireless access point connected to the switch that sends stuff out. And again, this wireless access point could be anything. And then obviously the clients then connect to the wireless access point. Now, your wireless access point can come in two flavors. It can be what they call an autonomous access point, which means you configure each wireless access point on its own. So if I have 10 wireless access points in my network, I got to configure each one individually and then install and blah. So if one goes down, I got to go and configure it myself manually. Whereas over here, you've got a wireless LAN controller. And that allows you to go to the controller, and the controller can push out wireless access configurations to the wireless access points. So they call these access points like this. Right, so the controller's over here, and it pushes out a config to the lightweight access point. So any access point designed around getting its config from a controller and not getting its config from the user or directly is called a lightweight access point. So there's autonomous that you set up yourself, and then there's lightweight that is meant to hook to a controller. All right, access points come in all kinds of shapes and sizes. Remember, Cisco is an enterprise company. Their stuff is designed for the enterprise, the big companies, General Electric, GM, that kind of stuff. So they don't compete very well in the small market, which is why they bought Netgear years back. Because they wanted to get into the small business market. So they bought Netgear, they grabbed some people out of Netgear, they designed their own products based on that, and then they sold Netgear to, Dell or something like that? But now they've got their own small business line of plastic parts made for small business that are under $100, things like that. So again, here's their small business line. They're typically black in color. Their access points are typically white, and they're about the size of a sandwich. And then they have the mid-level stuff that goes back to the Cisco green, and then you've got your stuff after that. All right, the majority of your wireless deployments are single wireless access points, each one controlled individually. I don't know any business except for maybe like a healthcare system that's using a wireless LAN controller. And last I looked, but again, this has been years ago, like our closest hospital has not been using a LAN controller. Because wireless access points, especially like the Cisco ones, once you put them up in the ceiling, they're pretty much good for, well, I don't want to say life, but they're good for a good solid 10 years. They don't just die like a Microsoft server does. So it's a lot easier to just, hey, I can save money, just buy the 10 access points, buy autonomous ones. I'll configure each of the 10 by themselves, pop them up in the ceiling, and I'm done. You can even deploy your wireless access points, your autonomous ones, in what they call a cluster, so that multiple access points can kind of work together on a single configuration. All right, again, for larger networks, now we're talking about, getting a wireless LAN controller, pushing out the config to everybody else remotely, and that kind of stuff. And then you get into a special kind of wireless access point, the Cisco Meraki cloud managed architecture. Again, I can't imagine what these cost. I know the 1200 series that we have at the school, with the add-on, radios. If you put 2 radios in there and the base, they're about $1,000 per access point. So you can see only the biggest businesses are using these. And that doesn't include, paying a couple $100s for the wireless LAN controller that can only control like 8 of these at a time. So then you might want to have to buy the bigger wireless LAN, so you can see how much money you can get in here. But again, if you're a huge company, like if you've ever been to a manufacturing facility for General Motors, they are huge. They have a huge manufacturing floor. They have offices spread throughout multiple buildings. So as the IT guy, the last thing you want to do is go run around different buildings and stuff and try to figure out where these access points are and try to figure out which one's broke and figure out where it's at. Because a lot of these are mounted in special places that are very hard to get to, or you may not be able to get to them, during working hours. So having lightweight access points all done through a controller is so much easier, because then you can just go to the controller and push out your new config or the solution to whatever your problem is, and without having to go and mess with that stuff. And it's nice and centrally located. So again, with the larger sizes, obviously money's no object, so you can really get into a lot of expensive stuff. Cisco, I don't know if they make the 1200 series stuff anymore. They have the 1600, the 2600, the 3600. Very expensive but very robust access points. And they even make, special ones to be outside. I have a friend of mine, and he actually is the IT consultant for a resort in Virginia, and he does all their wireless, and it's all outside. He's got several miles of campus that he has to have wireless over the whole thing. So they buy these high rugged access points with these huge antennas that can push out a bigger signal. But again, it's crazy expensive. All right, so how do you control these lightweight access points? Well, again, with the wireless LAN controller. So here's a small business one. This is a module that pops into your router that allows you to then control wireless access points from your router. And again, that goes in that big module slot on the 2811s. All right, Cisco AeroNet APs. Remember, Cisco has a special group or a special protocol for its wireless that you can turn on, and they're called the AeroNet extensions. And their access points obviously can all use the AeroNet extensions. And the AeroNet extensions allow it to use different things. But all of their APs can use, omnidirectional antennas. Remember, an omnidirectional antenna, the signal goes out like a donut, kind of like throwing a rock in a pond and see the waves going out. Then you have directional antennas that you can put down a hallway, which are really a Yagi antenna is a directional antenna that you can put down a hallway. All right, and then I don't know why they continue to talk about these different models here, but it's always on a test somewhere that it was still a question on the CCNA last time I took it. But anyway, whenever you have 2 wireless devices communicating without an access point, they call it an ad hoc network, or I believe it's an independent basic service set, an IBSS. But the typical name is what they call ad hoc. And then whenever you add a wireless access point, they call it a BSS, a basic service set. And then, so now they're talking about tethering, which used to be a lot more, I guess, common. Really here when they're talking about tethering, I don't know why they show you pictures of 2 laptops. What they're talking about is years ago when people had unlimited data plans on their cell phones, a lot of students would come in and they would use their cell phone with a little adapter and turn their cell phone into a wireless hotspot. And they could actually give out faster wireless speed through the 4G than we were getting, through our wired through Stark State. And it was kind of cool. But obviously then all the phone plans changed. Now everybody had to pay for the data, and then people quit doing it. So here you have that basic service set, the BSS. You've got one access point, one or more access points all connected to one wireless access point. So if you've only got one wireless access point, you have a basic service set. Most of us at home just have a BSS. But remember, if you have no access point, just a bunch of wireless devices, you have an IBSS, an independent basic service set, also called an ad hoc. All right, and then you add multiple wireless access points, and then you have an extended service set, an ESS. So make sure going into the test for the CCNA, you understand that the ad hoc, the BSS, and the ESS. Why they make that a big thing, I don't know. I mean, most businesses have multiple access points to do their entire building. They have VLAN so they can have a guest network and a public network, things like that. All right, moving on to wireless LAN operations. Here's the 802.11 frame. And again, as far as the CCNA goes, don't focus, try to memorize all the frames. You need to be able to identify, an IP, a UDP, and a TCP frame. Those are the only frames you need to identify. All these others where they show you, hey, here's a VLAN tag, and hey, here's the wireless frame, and hey, here's this frame, here's the layer 2 frame. You don't have to memorize all these frames. When a problem occurs and you pull out Wireshark and you start sniffing this stuff to look for things, you can always go Google it and see what the frame is supposed to look like and get information. Plus, when you use Wireshark and you get in there, you can see the information, who's sending the frame, where's the frame supposed to be going to, things like that. So you can kind of usually see these errors without having to build the frame in your head or identify that stuff. Now, once you get on the job and your job is a lot more focused on troubleshooting, then you want to really get into Wireshark and the frame types and things like that. But if you're studying for the CCNA, with all the different topics they have, routing, switching, wireless, cabling, IP math, the last thing you want to do is add another subject and start trying to memorize all these different frame types. I mean, you can go crazy doing that stuff. All right, so again, don't forget Wireshark is free. You can grab it. You can see all the different frames as they're going across. And then you can check out the wireless ones. Now, don't forget your wireless stuff is all out there in the open, so anybody at Starbucks can open up Wireshark and see your frames. Because obviously most places like McDonald's or McDonald's or Starbucks do not have security in place. You just connect openly. So your stuff is not encrypted. All right, so then we got 3 pages of frames. Hey, here's our wireless frame type. Hey, here's the management frame. And here's a control frame. Great. We'll just totally ignore that. All right, don't forget, wireless works with carrier sense multiple access with collision avoidance, which means when a wireless device wants to talk, he sends a request to send, an RTS. And then he waits for a clear to send. Once the clear to send is received, he transmits his data. But if the clear to send is not received, he waits for a random amount of time, and then he transmits his request to send again. So you can sit there and say, hey, I request to send. Oh, no answer, so I'll wait a minute. Okay, now I'm going to request to send again. No answer, got to wait a minute. So it's time sharing. There are no collisions because the wireless access point only talks to one person at a time, which is why the more people you have on an access point, the slower your data flows. All right, when we get into our access points, we got a couple terms we've got to remember. The first one is the SID, the service set ID number. It's just the name of the wireless device. And there's different trains of thought. You can broadcast it out so everybody can see it, so they know which networks are there. Obviously, especially with a guest network, for your customers, you want to be broadcasting that out so they know it's there and they can connect. But with a business network, you may not want to broadcast your network, so when somebody scans the wireless, they're not seeing that broadcast, so they don't know that your network is there. Now, with that being said, somebody that actually specializes in hacking, there are hacking tools to allow him to see those wireless networks out there that are not being broadcast. So it does not stop them, but it does stop the common, everyday, normal person. So unless you're into a highly secure, you're working for the CIA, you're working for a big financial company, things like that, where you actually do have hackers actively coming after you, you're probably okay to just disable the SID. But remember, when you disable the SID on all your wireless devices, you've got to put that SID in there manually. And that way they'll say, hey, they'll send out a probe saying, hey, I'm looking for this network. And then the wireless access point says, oh, hey, I'm on that SID. I'll connect to you. And that's kind of how it works. All right, again, password, whether you're setting up WEP, WPA, you've got to put a password in there. And then what network mode you're in. Wireless access points can operate in multiple modes. Like my G allows me to put on the B radio and the G radio, or just the B radio, or just the G radio, that kind of thing. You typically only want to turn on the radio that you're using. Obviously, it saves power, it prevents your access point from overheating, things like that. Then you've got your security modes. Remember, you got no security. Then you have WEP, which is just like no security. Then you have WPA and WPA2. Now remember, WPA and WPA2 are both crackable very easily if you set a weak password and somebody's able to guess your password. So even if you do WPA or WPA2, you still need a strong password, a phrase, I love money $, something like that. Something with an uppercase letter, a lowercase letter, a special character that is a phrase. Any word in the dictionary can be guessed. I can't tell you how many dictionary file password attack things are out there on the web. If you do a search, you'll find millions of them. So by just putting in Sparky5, that's not somebody's still going to get in your wireless. Obviously, and then your channel settings. Remember, with a lot of them, like the G protocol that's still very common, there are only 11 channels, and only 1, 6, and 11 do not overlap. So really, you only have 3 channel choices, 1, 6, or 11. I think most access points ship with channel 1 as the active channel. So you want to use some kind of a scanner, like a free one like Insider, and scan in your area and see, like especially if you're in an apartment building, if 5 people have wireless around your apartment, and they're all on channel 1, well, then you want to switch yours to 6 or 11. All right, and then again, for discovering your access point, with passive mode, the access point advertises its service by sending beacons. So basically, your wireless access point is broadcasting your SID, hey, this SID is available, hey, this SID is available, hey, this SID is available. And then when you go on your device and you say, hey, show me available wireless networks, it shows up. Why it's called passive mode? Because it's passive for the client. The client doesn't have to have anything, and he'll be able to see the access point. Active mode means you have to actively put in the name of your SID in order for your client to even find the access point. So remember, access points send out beacons whenever they're set to broadcast, and the beacons go out, and that's why everybody can see all the wireless networks that are in your area. But if you're not broadcasting, there are no beacons. So then your client has to send a probe to ask if this network's out there. So at my house, let's say I turn off my SID, so my SID's not broadcasting anywhere. So on my laptop, I type in, JMac Home Network as the SID, and then my laptop says, hey, he just starts sending out probes and saying, hey, is this network available? Well, if I'm at school, the network's not going to be available, so he's not going to connect. But as soon as I come home, that wireless laptop is sending out these probes, and then the wireless access point is like, oh, hey, wait a minute, I'm JMac Wireless. You can connect to me. And then they make the connection. All right, and again, with your authentication, you can have no authentication, which used to be the standard way back when, and that was terrible. Or you can have a shared key, like WEP, something like that. All right, and then frequency channel saturation. There are a couple different types of ways or that your access point can access different channels or different frequencies. And what typically happens is, other than A and B, everything else uses multiple ones. So you may use, FHSS at the higher bands, 54 megabits per second, 30-something megabits per second. But once you fall down to 11 megabits per second, you've got to go down to a lower frequency. So then your wireless access point switches over to DSSS frequency, so he can then scan those lower bands. So DSSS, FHSS, and OFDM are all just different frequency detectors or scanners to allow you to communicate on those different frequencies. Remember, the farther away you get, the lower frequency, the lower your speed is, so you have to drop to a different channel technique in order to send data. If I don't have enough signal to send something at 54 megabits per second, then I probably can't send the same data, at 11 megabits per second. I got to change the way I format the packets. I got to change the way I'm using that channel, and they call these they're all spread spectrum techniques. And again, OFDM. So as you get into different access points, G and AC, the higher you go, you may start with OFDM, and then switch to another one, then switch to another one as your signal becomes shorter or smaller. All right, and then so again they're showing, hey, hey, radio spectrum with electromagnetic blah, blah, blah. So remember, microwave frequencies do interfere at the 2.4 range. Microwave messes up the B, the G, the N, the AD. So microwaves, always bad because they do all kinds of weird stuff. All right, don't forget your channels. When we're talking about B or G, there are only 11 channels used in the U.S., and only 3 of them are non-overlapping, 1, 6, and 11. You will probably see that somewhere on the CCNA. But, and again, that's the 2.4 range. If you switch over to the 5 gigahertz range, now you've got more space between channels, and the 5 gigahertz band is less crowded. So the 5 gigahertz band has 4 non-overlapping channels. And as far as I know, you did not have to memorize these, but they're 2.41, 2.43, 2.45, and 2.47. So you start at 2.41, and then you just add 0.02. So 41, 43, 45, 47. Now, that's the N protocol with backward compatibility to G. N protocol by itself, if you're just running N, you can go actually at 40 megahertz, and then you can have 2 channels, but each channel offers 40 megahertz of range. All right, and then when you're planning your deployment, what I typically do, or what my company does, when we go in, somebody says, hey, we need to install wireless, or we need our wireless fixed, it's something bad. We ask them, do you have a blueprint of the building? 9 times out of 10, no. But they always have a evacuation plan or a fire plan. You are here, and here's how you get out. So we use those, and then there's actually mapping software, like there's the Yukonuba heat mapper. Actually, that's not really the name Yukonuba, but something like that, that allows you to put these maps in, and then you carry a wireless laptop around or on a cart, and as you push it, it's taking frequencies, and you put like here's where I'm at on the map now, here's where I'm at on the map now, and it actually does a heat map to show you how strong the signal is in each room, in the corners of the rooms, things like that. So it's really nice. Customers eat that up. If you can show them the actual, what they call the heat map, or where their signals are strong and where their signals are weak in a graph with their blueprint, they're all over you. They think you're the most professional thing that they've ever seen in their life. As opposed to Joe Bob going in and saying, oh yeah, you got some weak signal in this room, I can boost that blah blah blah. But you get the idea. Woo, it's going to be a long chapter. All right, so security. Now, with your security, you've got all kinds of different threats. You got problems with people trying to break into your wireless. You got problems with people trying to grab your wireless. You got problems with people trying to shut your wireless down so you can't use it. And then you have what they call rogue access points, people trying to put access points up in your ceiling so that when users connect to it, there actually is no security, and they can grab the data, they can steal it. So imagine you work at a bank, and for some reason somebody goes into the bathroom, cuts one of the data cables up in the ceiling, and puts an access point and names it the same wireless SID name as you have. So let's say you work for First Merit. So your wireless SID, your network is First Merit Wireless. So they change their access point to say First Merit Wireless, and then they put a new RJ45 on the wire they cut, and they plug it in, and then they walk away. Well, this new one shows up for everybody, so they still connect to it. They're still typing in passwords and connecting to servers and things like that. But the new one doesn't have any WAP, WPA, any kind of security. So these guys are logging all that stuff, and they're able to grab your stuff. So that's a rogue access point. Again, denial of service attack. We're just trying to stop somebody's wireless from working so they can't use it. We're not trying to grab data, do things like that. We're just trying to prevent it from working. And the 2.4 range obviously is more prone to interference than the 5 gigahertz range, because 5 gigahertz, there's hardly any devices that use 5 gig. Almost everything, cell phones, microwaves, everything uses 2.4. So there's all kinds of ways to do denial of service attacks. You can do what they call a Smurf attack and send a bunch of pings based on from another IP address, so they all hit you. In this case, we're sending disassociate commands to keep all the clients from actually connecting, because they keep dropping off the network with a disassociation command. A clear to send flood, taking advantage of the CCNA to grab all the time from the wireless access point so it doesn't share any time with the wireless client. That kind of stuff. Most of the time for those kind of attacks, obviously the attacker typically has to be close, but not all the time. Remember, If you've ever watched a video of a cantenna, somebody can be a mile away with a homemade powered antenna, and they can actually access your wireless where you're at. So they don't have to really be that close. Then again, the rogue access point that we already talked about, where somebody pops one up in your roof and it has the same name as you, so that people will connect and use their passwords. All right, man in the middle of attack, basically you're trying to get in the middle between a user and something else. Typically it's the user and the router. So I'm trying to convince the router that I'm the user, and I convince the user that I'm the router. Then every time the user wants to use the router, they send their packets to me, and then I forward them to the router. So the user has no idea anything's going on, and really I'm intercepting all the packets that come and go. So I'm in the middle between two different things. All right, for wireless security, with shared key, you got three options. You got WEP, which is very weak. Any high school kid is going to crack that in 10 minutes, no matter how strong your password is. Then you have WPA and WPA2. Obviously, WPA2, the encryption is stronger than WPA, but both of them can be cracked if you use a weak password. Don't be that person. All right, so again, WEP, obsolete. That's all you need to know. WPA is acceptable. I mean, it does have strong encryption. If you use a strong password, WPA will typically be fine for the majority of users. The problem is, for our password, we always want to use something like, oh, you know, Brittany1 or that kind of stuff, which is crappy. And then we have WPA2. WPA2 with AES or EAP is the strongest that's out there. But again, it all comes down to the password. If your password is Sparky, it's going to be in my dictionary file, and it may take me a little longer, but eventually I'm going to crack your WPA2. Okay, then along with your authentication method, remember we have authentication, I am who I say I am, and then we have encryption. How do I cover the packet up? And your choices are really TKIP and AES. AES is the strongest. So there's AES followed by TKIP followed by nothing. So with WPA or WPA2, when you set those up, it'll ask you, do you want WPA with TKIP or AES? 9 times out of 10, you want the AES. But don't forget, every time I turn on encryption, I got to wrap my packet up and then send it to you, and then you have to unwrap it. So it adds overhead to the packet. It slows your network. All right, and then I can pick personal or enterprise. Personal just means there's no server. We're going to do the authentication on the wireless access point. Enterprise typically means I'm going to use a Radius server, and Radius is remote authentication dial-in user service. With what happens with Radius, the user tries to connect to the access point, and he sends his username and password. The access point then forwards that information over to a Radius server. And then the Radius server just says yes or no. So then that yes or no comes back to the access point, and then he lets the client know. And that way, if for some reason the access point is ever compromised, whoever compromised it does not get access to all the passwords because they're actually stored on the Radius server itself. So here's the the GUI for a wireless access point, and then here's the Radius settings. Now you can't really see them in the slide; they're kind of crappy. But basically, you put the IP, the name, what you're going to use, and then where you're going to send it to. And we won't do Radius in class, but we will be using the GUI to set up some access points. All right, configuration. Holy crap, we're about 40 minutes in. All right, before you install wireless, you've got to have some settings. You got to know what the SID's going to be, what your network password's going to be, if there's a router password, because we're going to do an interface on a router, a guest network name, a guest network password. Basically, what most places do is they have a sheet for each access point that's set up, where they have all the information down. Here's the IP address, here's the MAC address, here's the version of the software, here's what the SID is, that kind of stuff. So, to turn it on, you're going to start the WAN implementation process with a single AP. So you install one AP, you see how it works, you work on the settings, you get a client to go, and typically you do this without wireless security. We're just trying to get the connection going first. And then once I get the connection going, then I turn on the security. By doing it in 2 steps, if I turn everything on and then there's a problem, I don't know where the problem is. Is it with the connection from the client to the access point? Or is it because my security settings are wrong and something's not matching? So then you got to go pull out Wireshark and try to figure it out, and it's a pain. So that's why you want to do these one step at a time. no security, client can connect. Then I do security, client can't connect. Well, then I know obviously it's a security setting and I can just go fix it. All right, nowadays even the small business stuff has a GUI setting. So here's one for the Linksys router. Hey, now remember, I do not recommend ever using the setup CD from these devices. I prefer to just plug in, get into the GUI, and make all my settings manually. I don't like to do automatic stuff because they don't know what I want and they may skip settings. All right, so again, there's other settings on here that you can do. Remember, the small office ones are also just like your home ones. They do routing, they do switching, they do firewall. You can do NAT through them, all kinds of different things. So, smart Wi-Fi enables you to configure your router's basic settings on the local network, blah, blah. So basically, they allow you to diagnose and to set up different things. Again, I don't like to use the GUI. I like to just plug myself in. Use the GUI and configure it. I don't like to use the auto install programs. They just never seem to do what I want them to do. All right, some tools. There's the device list, that lists who's connected to the wireless LAN. You want to name your devices so you know where they are and what model number it is. You may have one in administration, so admin, 2811, something like that, or whatever the model number of the wireless access point is. And then guest access. If I've got a public and a private network, I want to make sure that my guests can all access their network and not mine. Parental controls. Do I want to keep my kid from viewing porn? Is there anything I want to prioritize? Maybe it's the World of Warcraft server, something like that. I want to test my speeds by downloading and uploading files. And if I have USB storage, a lot of these devices nowadays have a USB port that you can connect to a USB hard drive, and then everybody can use it. Like I think Netgear has ReadyBoost or ReadyShare, that any wireless user or a plugged-in user to that device can then access that USB device, which is kind of nice. All right, and then most devices nowadays allow you to back up the configuration to your PC or something like that, so that if something happens to your wireless access point, you can just go get a new one, and then push your config back onto it, and you're right back in business. All right, connecting to a wireless access point, again, pretty easy. Most of the time we're broadcasting our SID. You go to your wireless access card, you hit, hey, search for available networks, you see your network, you hit connect, and then it may ask you for a password, you type in that password, and you're all set. All right, if you have issues, it all depends. Some people like to start from the bottom and start at layer 1. Is my network card seated? Is my antenna up? Am I too far away from the access point? Stuff like that. Or they want to start from the top down. Is it a network issue? Is it, do I have the right IP address? Is the firewall blocking me with an ACL or something like that? Or you can divide and conquer. Hey, you go look at the access point. I'll stay here and play with the client, and I'll call you in 10 minutes, and we'll do notes and go from there. All right, these are just amazing graphs. Hey, this client can connect. But again, if this client can't connect, but the other clients can connect, hey, obviously my wireless seems to be good. I might want to bring one of these clients over here to see if he can connect. And then if he can, then I know it's the client. So there's something wrong with the client side. So that's typically what we do, is we break the stuff up. Hey, okay, my client can't get to my wireless access point. Well, can my client get to another wireless access point? Can my client, use this, plug into the wired network and get there? That kind of thing. And that way I know, is it a client issue? Is it a WAN card issue? Is it the wireless access point issue? All right, the biggest complaint we get from users is their network is slow. And a lot of home users get this. And what happens is, you got a family of 4, and you got 2 teenagers, and then you got like a 9-year-old who has a phone, and then you got a 5-year-old. Well, the 5-year-old is watching Netflix. The other 3 all have cell phones, and their cell phones are set to connect to the wireless network. Their cell phones also have apps that are grabbing the temperature constantly and the time of day and updating this and connecting to the Apple Store and crap like that. The mom's using, the PC, and the dad's using the iPad for something else. So basically, you got all these users all sharing the wireless. So remember, each user that jumps on there is a timeshare, so it's less time for you. All right, you probably don't have to do this very often. I have never had to do this because I needed to, but usually you can update the firmware on your wireless access point. Now, the only time I've done this, one time I had a Linksys router that I constantly had to reset, like every couple of days I had to reboot the thing because it just wouldn't work right. So what I did was I bought a new wireless access point, and on the Linksys, I stripped off the firmware, and I put on, was it WRT 66 or something like that, and then I was able to turn it into a repeater, because that added extra functionality. Then I was able to put that out into my neighbor's garage so that he could get wireless out to his backyard and to his neighbor, stuff like that. But for some reason, if there's some feature you want in the new firmware. Now remember, we're talking about software that runs the chip. You're not gonna be able to download a firmware and go from G to N protocol. It's not going to add a radio to your wireless access point. It's typically going to fix any security leaks, things like that, that may have been issues on that thing. So for the regular home user, 9 times out of 10, you're not going to update your firmware. But nowadays they make it a lot more easy. You can just click, hey, check for updates, and it updates itself. A lot of times when you update the firmware, it wipes off the config of the router, so you may want to make sure you save that first. Alright, and with that, oh, we're finally done. Oh, so much information. So when you guys come to class, blah, 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 we're going to set up a wireless access point. I've got some Cisco small business ones, I've got the home ones, and I've got the regular business ones, I think the 1130s. So there's 3 different access points that you can set up and see the difference between them. Obviously the 1130s are the Cisco white ones. They require you to plug in with a console cable and configure just like you would a router. The other ones are just GUIs. You plug your network cable in, and then you type in 192.168.0.1, and you're all in, and then you're in the GUI and play with them. So that's what we're going to do on lab day. So that's your wireless class. Oh, I'm so tired. I can't believe this lab went this long. So we'll see you later.